session, we will learn about stepper motor interfacing in AVR microcontroller. So there will be two parts. In part one, we will discuss the background of the topic, and in the second part, we will discuss the circuit diagram and the coding. So at the end of the session, we will be able to run stepper motor for a specific rotation by using AVR microcontroller. So let us start the topic. So stepper motors actually translate electrical pulses which we apply to the motor, and the stepper motor translates those pulses into mechanical movements. So the mechanical movement, which is a specific degree of rotation, it depends on the electrical pulses. So electrical pulses play a very important role in stepper motor running. These electrical pulses will be called as the sequences. There are different types of sequences which can be applied to stepper motors. And further, we will know that there are more than two terminals with stepper motors, because usually in the motors which we study, like common DC motor or AC induction motors, they have two terminals, but the stepper motors have more than two terminals. So according to the number of terminals, we apply different pulses at the inputs of the motor. So this is the basic introduction. Now let us discuss about the applications. So basically, the stepper motor is used for position control systems. So there are two types of control systems. One is speed control systems and others are position control systems. So whenever we need position control systems, then stepper motor is one of the choices. Other choices may be servo motors. So the applications like disk drives, dot matrix printers, and in many areas and domains of robotics, we use stepper motors. Like whenever we want to move the robots, its different joints, then we use stepper motors there. So it is very interesting to know about the stepper motors interfacing with controllers. And the stepper motors commonly have permanent magnet, uh, and which is actually the shaft. So the permanent magnet part, the shaft, is this one, which is in between these stator poles. So these are stator poles. So stator poles have actually a the stator poles are A, B, C, D shown here. They can't move, while the shaft, which is in the center, it is also a permanent magnet actually. So it moves like here. So depending on the polarities of these windings, which are wound across these stator poles, the magnetic properties inside the stepper motor changes. So north and south poles, we know that the basic principle is that the same poles repel each other and the different poles attract each other. So in this way, stepper motor moves uh, according to our applied pulses at these inputs. So actually inputs are applied with these stator windings. So depending on those pulses, stepper motor moves with different degree. So we can move the stepper motor for let's 10 degree, 20, 40, whatever we need. So it is the electrical pulses which control the rotation of the stepper motors. So next we will discuss about how stepper motor rotates in detail, in bit detail. So stepper motors actually rotate on the basis of the electrical pulses. So the diagram shown over here is the internal winding diagram of stepper motor. So there are four windings. So this is actually four-phase stepper motor, which is also called a unipolar step motor. So there are other types of stepper motors as well, but this is more common type of stepper motor. It has four windings, but it has six number of terminals or leads. How these are six? It is like this, that actually the two windings are joined at one ends and the common point is taken out, and similarly the other two windings are joined at one end and another common point is uh, got. So common points are two and other points which are related to each winding are four. So there are total six terminals. So the six terminals of this unipolar motor are there. So actually to rotate for a specific degree, we apply electrical pulses at these four uh, terminals which are winding A, B, C and D. So in this table, we can see that there are columns winding A, winding B, C and winding D. And further, the common terminals are actually applied with 5 volt uh, voltage. So here we can see that there is a clockwise and anti-clockwise arrows. So what does it mean? That we can rotate stepper motor in clockwise direction like this, or in anti-clockwise or counterclockwise direction. So to do so, how we do this? Actually, we apply the pulses in this sequence. Let first we apply this sequence which is 1001. So that is at winding A, we apply 1 and which is high voltage, basically digital 5 volt, and winding B is 0, winding C is 0 and winding D is 1. Okay, then next if we apply 1100 according to the winding, and then we apply 0110 and then 0011, and let we repeat this sequence, then the motor will rotate in clockwise direction. But if we reverse the sequence, if we start from, let here, from fourth step 0011 and then we apply the third step which is 0110 and then 010 and 1001, then motor will rotate in counterclockwise direction. And important point is that it doesn't matter from which step we start rotating the motor, but important point is that from whatever step we start moving the motor, let it is step number 2, 1100. And if we are interested to move it in clockwise direction, then it is important that we will have to apply next step 3, which is 0110, and then step 0011 and so on. And if we were interested in counterclockwise direction, then after step 2 we will apply step 1, then step 4, 3, 2, 1, 4, 3, 2, 1 and so on. The motor will continue rotating in counterclockwise direction. So next, with more detail about the rotation of stepper motor. So how this polarity is changed? So it is basically a change of current direction through the windings with the help of center tap terminals. So by changing the winding pulses at winding A, B, C, D according to these sequences, we can change the direction through windings and thereby we change the polarities inside the stepper motor. And in this way, we are able to rotate the stepper motor in clockwise direction or anti-clockwise direction and for a specific degree. So next in the discussion we will discuss in detail how far we can control the stepper motor for a specific degrees. Till now we have discussed the direction of rotation of stepper motor, and the idea behind the stepping is that we apply different pulses at all the windings. So these pulses are changed in stepwise. Like here it is 4-step sequence. So there are other types of sequences also which can be applied. So each sequence has different objective. We will discuss more sequences, but this is a common four-step sequence to rotate the stepper motor. So what is step angle? It is very important concept. It is related to how much movement is associated with a single step. So actually the step angle is the minimum degree of rotation which a motor can rotate. So different motors have different step angles. So there are different stepper motors available in the market which have different step angles, and according to requirement we find the motor. So actually how this step angle, which is the minimum degree of rotation of that motor, is determined. It is actually a internal construction dependent parameter which we can't change later on through coding or programming. So it is actually the construction in such a way that there is a number of teeth on stator as well as on rotor which determine how larger or how smaller will be a step angle of a particular motor. Step angle depends on the teeth on stator and the rotor. So various motors have different step angles. Like here there are about 6 or 7 stepper motors. Each motor has different step angle. Let this is motor of step angle 0.72 and this is of 15 degree. So this motor moves in larger degrees. So with each step it covers 15 degree and this motor covers only 0.72 degree. So there are other motors also available which can have different step angles. So we can easily infer that if this is a step angle, let this is step angle motor 2, then how much would be the steps per revolution? Whereas we know that revolution we consider as of 360 degree, the complete revolution of a motor. So if there is a 360-degree revolution and the motor is of step angle 2, then total number of steps per revolution would be 180. So in 180 steps, the motor will complete one revolution. So in this way, we can calculate the number of steps per revolution for each of the motors. So next, we discuss about the steps per second, and the related parameters are revolutions per minute and steps per revolution. So how we can determine about the steps per second of a particular motor, that how much steps will be covered in 1 second. So we will actually multiply revolutions per minute parameter with steps per revolution. In previous slide we discussed about steps per revolution. That will be multiplied with revolutions per minute, and if we divide the number with 60, then we will be able to get steps per second. So we can get steps per second. So actually steps per second is the parameter which is related to motor speed. So although the specific purpose of the stepper motor is the position control, that it is moved or rotated for a specific degree, but obviously there is associated parameter, and which is the speed of that rotation, that how fast or how slow that stepper motor covers the particular rotation. And let we want to rotate stepper motor for 20 degree, then there may be different choices, that whether we want to get 20-degree rotation in 2 seconds or 5 seconds. So depending on the application like robotics or other, we can control the speed. So how can we control the speed of that rotation? So it is actually done through coding. We will discuss in the coding part that that the function of delays can be configured for different speeds of rotation per stepper motor. So next, uh, it is the four-step sequence and number of teeth on rotor, how they determine that how much movement will be associated with applying the four-step sequences mentioned earlier. So it is very important to know that whenever we want to move stepper motor for a certain number of degrees, let 20, 40, 60, 80, or whatever it is, then we have to calculate about how much is required the steps, four steps to be applied to motor. So to understand this, let us look over example 2 of the reference book, which is given at the end of the slides. So actually the task was that a stepper motor is to rotate it for 80-degree movement. So we can roughly imagine that if this is a reference point of the motor shaft, then we want to move till this point, which is 80 degree. So we know that this is about 80-degree movement. So to move this much in that counterclockwise direction, or it may be clockwise, whatever it is, but actually main requirement is that we are to move it for 80 degree. However, it is yes important whether we want it to move clockwise or anti-clockwise. For that purpose, we have discussed in the previous slides that we are to reverse the sequences. Let this four-step sequence, these are four steps we are discussing again and again. If we apply these sequences in this direction, then the motor will rotate in clockwise direction, and if we apply in upward or reverse direction these sequences, then the motor will rotate in counterclockwise direction. One important point is that uh, at a time, obviously, you will be able to understand that we apply one step sequence, this 1001, or at the four terminals of motor ABCD, and after some time, which is the delay function, we apply next sequence 1100. So all these step sequences which we apply and create some delay to get desired speed of the rotation of the motor, we use coding. So we don't apply manually, obviously, these step sequences. We don't uh, make switches on and off for these windings sequences. We actually code, we write program such that these voltage sequences are applied at the windings of motor. So accordingly, motor moves. So come back towards our objective. So actually the motor has 2-degree step angle. So there is a restriction such that the motor has a step angle of 2 degree. In the previous slides, we discussed that different motors may have different step angles. So if a motor has 2 degree step angle, it means the steps per revolution would be 180. That is, in 180 steps, it will cover the complete rotation of 360 degree. So actually question is that for how many times this four-step sequence. So this is four-step sequence. So for how many times this should be applied so that the motor may move for this 80-degree rotational objective. So for that we know that the motor is of step angle 2 degree. So steps per revolution will be 180. So the number of rotor teeth are 45. So if the number of rotor teeth are 45 degree, then how many times will be the step sequence applied? So here it is important point that for one time or per four-step sequence, that is, if we apply step 1, step 2, step 3, step 4, this will be called per four-step sequence. So all these four sequences application means that it will be counted as one four-step sequence application. For this, it moves the motor for 8 degrees. How it is determined? It is actually that the rotor teeth are used for this purpose, that 360 divided by 45, which are the rotor teeth, whereas 360 is complete revolution. So we get 8. So whatever is the rotor teeth of a motor that will be divided with 360, which is complete revolution. So this number is actually the degrees moved for per four-step sequence of that motor. So we have now come to the point that if we apply one time this four-step sequence, then this motor will move for 8 degree. But we are interested to move this motor for 80 degree. So it is now a very simple problem. We can infer that to move for 80 degree, we will have to do this process for 10 times, because for one time it moved 8 degree, and if we apply this process for 10 times, then 10 into 8, this 10 into 8, whereas this is overall 8 factor according to this step. So 80 degree movement will be achieved. So in this way we can achieve any other movement, like if we were interested to move for 96 degree instead of 80 degree, then how many times we will be applying this uh, four-step sequence? To move for 96 degree, will have to move we will have to apply this four-step sequence for 12 number of times instead of 10 times. So this is one time, 1, 2, 3, 4. This is only one time. Note that this is not four times. By applying all these four steps counts to one time. So one time, two, three, and for applying to 12 times, we will be able to move this stepper motor, which is of 2 degree step angle, to 96 degree. So next, we discuss about another step sequence, which is 8-step switching sequence. So now we will be applying 8 number of steps instead of 4. So what will be the advantage? Advantage will be to control the stepper motor for any precise or specific degree of rotation. That is, even if we want to rotate stepper motor which is of step angle 2, but we can rotate it for up to 1 degree precision by using this 8-step sequence. That is, for 4-step sequence, we were able to move stepper motor to let 2 degree, then 4 degree, 6 and 8, 10, 12 and so on. We were not able to move for 1, 2, 3, 4 degrees, that is to up to 1 degree. But with the help of this 8-step sequence, we can move the same stepper motor which was originally of step angle 2. We can move it for even up to 1 degree precision. That is, we can move it for 1 degree, for 3, 4, 5, 6 and so on. So this is the major advantage of 8-step sequence. So for example, we have discussed the 2 degree step angle. Now will be able to be controlled up to 1 degree step angle. So till now we discussed unipolar stepper motor, which was 4-phase motor. Actually, we also called it 4-phase motor. So there are actually 3 types of stepper motors commonly used. This was the unipolar motor we discussed till now, which has 6 number of terminals. So these are 4 terminals A, B, C and D, whereas these 2 middle terminals are center tapped, which are connected with 5 volt usually. So there are 6 number of terminals for unipolar motor. So whenever we find any stepper motor with 6 number of leads at the input or at terminals, then it is actually the unipolar stepper motor. So other types of stepper motors are bipolar, which has 4 number of terminals, and universal motor, which has 8 number of terminals. So it has 8 number of terminals, this has 6 and this has 4 number of terminals. So we can easily conclude that as universal motor has 8 number of terminals and unipolar has 6 and bipolar. So this is unipolar and bipolar has 4. So universal motor can be configured for all 3 modes. what it is meant that if we have purchased a universal motor which has 8 number of leads, then we can transform it to even unipolar or bipolar motors. How? Just by following this internal logic or configuration such that we will make common these two leads and these two leads, then it will become 6 terminal motor, this one. And if we uh, make another change, sorry, by changing this according to this fashion, we will be able to transform it into bipolar motor. And similarly, if we want to have 6 number of terminals for unipolar, then not only we will join these two, but we will take some common lead out of these, then we will have 6 terminals according to unipolar motor. So universal motor, why it is called universal motor? Because it can be configured into all other types of motors, whether unipolar or bipolar. Whereas unipolar motor can also be transformed into bipolar, according to that we will not be using these center tap terminals, only these 4 terminals will be used actually, so it will become a bipolar motor. So unipolar motor can also be used as a bipolar motor, whereas the bipolar motor can be only used for bipolar because it has limited number of terminals. So we have discussed part 1 of this topic. Now we will discuss the part 2, which is about wiring the stepper motor with AVR microcontroller and writing the code in assembly language and C language.